123 says determine the graph of a given quadratic function. Yesterday we started talking about what the difference was between what's a regular quadratic equation and what a quadratic function means. We've been dealing a lot with quadratic equations where you have something like 3x squared plus 6x minus 4 equals 0. What made it quadratic?
The x squared.
X squared. It has x squared. It's an equation. It's got x squared in it. This is what's a little bit different, is that this one is actually going to say y equals 2x squared plus 6x minus 4. When I said y equals, that's what makes it a function. And that's what makes it something I can graph. As opposed to just having a quadratic expression equals 0, I'm going to say y equals. And then on the right side is a quadratic expression. And you know, when we use our graphing calculator, we actually have a button for y equals. So anything that's y equals, we can put in our calculator and graph it. So let's talk about what they actually look like. And we've mentioned this word before, which is parabola. So the first thing says, which shows the graph of y equals x squared. And I chose this one because this is like the most basic quadratic equation to ever graph. Y equals x squared. And a lot of times we're going to actually call it the parent graph of the parent function. So that's this blank over here. Y equals x squared is the most basic quadratic function and often is considered the parent or the parent graph of the parent function. So we'll just put parent graph or parent function either way. I'm talking about the graph. So this is the parent graph. This is like the beginning first quadratic we're going to talk about. Y equals x squared. Now if you look at these four graphs, they're all what we call parabolas. Parabola is kind of this U-shaped thing. And A is the right answer. Go ahead and circle A. The most basic one looks like this. It's a U, and the vertex comes down and touches right here on the origin. So it's a parabola that touches on the origin. One other thing I want you to put, I wrote this over here in like the corner. This is considered to be opening up. So if it looks like a U, where it goes up, we call this opens up. So just right here, opens up. So when we have y equals x squared, we got a parabola that opens up. The one right below it, that's what I would consider opening down. So we got opens up and opens down. Some of these ones you're getting ready to see are going to open down. All quadratic functions are going to be parabolas. So you're going to see, we're going to look at these 4 examples in the back, I think. Yeah, 4 on the back. By the time we're done, though, we're going to use the graphing calculator. But by the time we're done, by the time we get to example 5, I think you should be able to just guess what you think the answer is going to be and not even have to graph it. Okay, the very first one on the back side says, which graph shows y equals negative x squared plus x plus 2. So this is quadratic. Go ahead and let's use our graphing calculator, though. And let's put this in for y equals. So go to y equals. And it was negative x squared plus x plus 2. Negative x squared plus x plus 2. And then let's go ahead and graph it. See what it looks like. So this one opens down. Now, obviously, all 4 answer choices open down. Which one matches up best with your graph answers?
A.
It's A. So go ahead and circle A, and I want to tell you 2 things about this to make a note of. Notice, if the x squared piece is negative, then our graph, our parabola, will open down. So if the x squared, that's the thing that's going to tell you if you open up or down. If x squared is negative, the parabola will open down, or downward. And then another thing I want to point out. Go ahead and circle this 2 that's in the equation. Circle that. Now notice, this parabola that's right here that opens down, where does it cross the y-axis?
2.
At 2. So take that 2 right there and point it right over here. Just make a little note. That number 2 right there, interesting enough, it does cross right there at that 2. Or right here. Make it more exact. All right, now let's look at the next one. I'm going to go ahead and go down. The next one, without even graphing it, look, is your x squared positive or negative?
Positive.
Positive. So what should you expect?
It's gonna go up.
Opening up as in A or C. So it's going to open up as in A or C. Let's go ahead and graph it. Put x squared plus 2x minus 3 into your graphing calculator. And let's see. We'll graph it. It's going to open up again. So between A and C, this one is more like what?
A.
A. But for a second time, notice this. Notice this minus 3 right here. Notice where you cross the y-axis right here. Might be a hint for something that you can like kind of pick up on these next ones. Y equals negative 1/3 x squared. All right, now here's the x squared piece. Is it positive or negative?
Negative.
So what do you expect it to do? Open down. As in answer B or C. But let's go ahead and look at it. See which one you kind of think it's more like. So here's my graph of it. Is it more like B or is it more like C? It's more like C. The thing to note is if the coefficient in front of the x squared, if it's a fraction between like 0 and 1, like 1/3, 1/4, 1/2, what that does is that makes the parabola wider or fatter. If the number out here is a whole number that's big, like 5, 6, 7, it actually makes the parabola skinnier. So we see a parabola that opens down, that's actually a little wider because it's 1/3. So that's why we're going to go with C. All right, here's the part where I want to see, before you even graph it, I want to see what you think about this one. It's got 3x squared, so what does that mean for opening up or down? It's going to open up, as in answer C and D. What do you think this -5 is going to do? It's going to cross the -5. So look at your two options.
It's D.
Between C and D, that crosses at +5, that crosses at -5. Now do graph it. Go ahead and graph in your graphing calculator and let's check. Let's make sure this one's a little different. It doesn't have an x piece. So let's just make sure. 3x squared and -5. Looks a lot like D. That's it. All right, so what makes something a quadratic function? We know quadratic means x squared. What's a quadratic function?
Y equals.
It's got y equals. And then you have those three pieces, those x squared, x, and number. And what's the shape called? Parabola. This U shape that you're seeing, they're called parabolas. How do you know if it opens up or it opens down?
Negative or positive.
Negative or positive where?
X squared.
X squared. If x squared is positive, you're going to see it open up. If x squared is negative, you're going to see it open down. And the very last thing is, what does that number out to the right tell us?
Where it crosses the y-axis.
Yeah, where it crosses the y-axis. So a lot of times you can get this without even graphing it. You know it opens up, you know where it crosses. And if you're looking at multiple choice, you can figure it out pretty easy. That's it. Objective 123 is pretty short and sweet, so we are ready to get started today.